Hello, class. Today, we're going to be discussing 10.2 Pythagorean theorem. So this is the first video for the last chapter in our Unit 4 material. So it's the last chapter for the semester. Uh, just in general, for a lot of people I know, like going through high school, there's some people that really like geometry, didn't like algebra, or vice versa. So just when I'm talking geometry, we're doing a basic geometry review. We're not going to be doing any proofs. We're going to be dealing mainly with perimeter area volume, a little bit of surface area, a little bit of Pythagorean theorem. I kind of like to, I think like Unit 2 and Unit 3 were kind of the heavy, like critical thinking parts of the course. It was like brand new stuff. I, I kind of like ending the semester on sort of a basic sort of topic, particularly because I know a lot of other classes tend to like really load you down at the end of the semester. So I kind of like to, when I can, make it a little bit more straightforward for the math classes. And so I think this is just a good straightforward topic. For the most part, it's going to be fairly basic. We are going to have, as always, there's going to be a few problems that are going to be a bit harder, particularly like with compound objects, which I mean like with a triangle and a rectangle together, or maybe objects that are missing some information that you have to find out before you can do the problem. So there's always a little bit of, those are like the higher level problems for this unit. Okay. And in Blackboard, if you're following with the lecture notes, there is just one document for all of chapter 10. And so that is the lecture notes for 10.2 through 10.5. So today we are just in the homework. There's only 5 problems from 10.2 on the Pythagorean theorem, and one of those is sort of a definition style problem. So this should be a fairly quick lecture. So let's just jump into the notes and see what we're doing with the Pythagorean theorem. All right. So anytime we're dealing with the Pythagorean theorem, this is one of the formulas that tends to get people tend to kind of remember, even if they don't know what everything applies to. But this is that a squared plus b squared equals c squared. So where does that come from? Well, anytime you're dealing with the Pythagorean theorem, there has to be a right triangle. And so right triangle is anything with a 90-degree angle, and the geometry symbol for that is like a little square in the corner. So that means that is the 90-degree angle. And you can only have one 90-degree angle in a triangle because all the angles have to add up to 180. So you can't have two 90 degrees because then that would be the total whole 180. All right. The other important thing is what's the A, the B, and the C? Well, the A and the B are what we call the legs. The A and the B are the ones that make up the 90-degree angle. And these are interchangeable. We could say B up here, A down here, but the A and the B are always the one adjacent to that 90-degree angle. The side opposite the 90-degree angle, that is our hypotenuse. That's the official name, but that's our C in the formula. So when you're setting up your Pythagorean theorem problems, make sure it's the C that's important. Like I said, the A and the B are interchangeable, but you got to get the C on the side by itself. And so when we're doing these Pythagorean theorem problems, as you can see over here, we're basically giving you 2 out of the 3 sides, and you have to figure out the missing side. So now let's just go through the math of that. These are pretty straightforward problems. All right, so use Pythagorean theorem to find the missing length in the right triangle. Use calculator to find square roots. We're going to talk about that. Rounding, if necessary, to the nearest tenth. Okay, so if these numbers are whole numbers, then that's great. If they're not, then we have to make sure on the calculator we can get the decimal answer and it has to be right. So how do we use the Pythagorean theorem? I'm always big on writing the theorem, the formula down to begin with. And so if you notice, we don't know C. That means we have A and B. It does not matter which one of these is A, which one of these is B. Those are the two that make up the 90 degrees. So I'm going to say my A is 12, my B is 16. So now we just plug those into the formula. So A squared is going to be 12 squared. Now we're dealing with length, so the answer is going to be miles. So I'm just going to leave that out of the formula because in the end, that's going to be miles as well. So I'm just focusing on the numbers. So a squared is 12 squared plus b squared, which is 16 squared, equals c squared. So now we just need to square both of those numbers. 12 squared is 144. 16 squared is 256. That's equal to c squared. And so now we add those. 400. Okay. All right. So now here's the question is what is c? We have c squared, but we need c. So how do we solve for c? And we briefly talked about this in unit 1, but basically we need to do the opposite of squaring something. Well, the opposite of squaring something is taking the square root. So what we do, once we have that square term by itself, which by itself is important, it'll come up later, you take the square root of both sides. The reason we're doing that is the squared are opposite operations, so they basically cancel each other out, and we're going to be left with just c. Now, normally, anytime you take the square root of both sides, you got to do plus or minus, but we're dealing in distance. Distance is always positive, so we don't need the negative on this. So we just need the square root of 400, and make sure you can do square roots on your calculator for the ones that typically use in class. And in most calculators, your square root is going to be above your squared button. And so make sure you know how to put that in your calculator. For these, it's just do second and then the square root, and then hit enter. And so we're getting a whole number, so we don't have to worry about decimals. So that says that hypotenuse for this triangle is 20 miles, which MATLAB tends to put the units outside the answer box. So you can kind of ignore that, which I don't like, but they're really kind of focusing on the number. All right, so this is a pretty typical problem. We're given the legs, we're trying to find the hypotenuse, plug in those numbers, do the arithmetic, and then since you're trying to get c squared, just take a square to both sides. Okay. What happens if let's see, that three is pretty much the same as 2 because we're still trying to find the hypotenuse. I'm going to skip down to 4. So now we don't know a. We got a squared plus b squared equals c squared. Always start with your formula. Okay, we don't know a in this case. That's going to stay a squared. Now, which one is b? Is it the 7 or the 11? Well, the a and the b always make up your right angle. So that is your b. And then your opposite, the right angle, is your c. So b squared is going to be 7 squared. C squared is going to be 11 squared. Now, how do you solve for a? Well, this is one of those reasons, this unit in particular is one of the reasons back at the end of unit 1, we did all that formula stuff so that we could use those skills here. The first thing we need to do is square both of those numbers. A squared plus 49 equals 121. And so now, how do we solve for a? We don't want a squared, we want a. Well, the one thing you don't want to do right now is we don't want to take the square root of both sides yet because we need the square term by itself. So before we can take the square root, we need to move that 49 over. We're going to subtract 49 from both sides. So we get a squared equal to 72. All right, now we have the a by itself, or sorry, the a squared by itself. So now we can take the square root of both sides. So the squared cancel out. So now we're doing square root of 72. Do second square root 72. Now notice that my calculator is giving me 6 square root of 2. Right? Because what they're doing is they're simplifying the radical, but in MATLAB, they want the decimal approximation. And so if your calculator is set up, because basically what's happening right here is on the mode. Sorry, trying to deal with that glare so you can also see it. This calculator and a lot of calculators, if you see down at the bottom, there's classic and math print. Math print is one that it's like fraction friendly, and it also gives us the square root answer, which that's often what we want, but now we want the decimals. I would leave that in math print mode. But if you want to convert that to a decimal for these calculators, that double arrow above the enter takes it to a decimal. A lot of calculators have like an S to D button, I think for scientific, for standard to decimal, but it's usually right above the equals. And so this is where you need to play around with your calculator, make sure you're getting a decimal answer if it's not a whole number. And so and they also said they want to go to the nearest tenth, and back in the early instructions. So that means that 4 is what we're rounding. The 8 says add 1 to the 4, so that would be 8.5. Approximately 8.5. Now, one thing that's sort of like a red flag is the hypotenuse. That C is always the longest one. So if you get an answer that's bigger than 11, to me that would have been a red flag because this has to be the longest side. The legs are always shorter than the hypotenuse. So just kind of keep that in mind if you're kind of doing a general check, if your answer makes sense or not. That's the core Pythagorean theorem problems, right? If you are looking for the hypotenuse, then that goes really kind of quick because you just put those in, take the square root of both sides. If you know the hypotenuse and don't know the leg, then it's a little bit more work because you have to subtract that over before you can take the square root. And then if it's not a whole number, then you got to make sure to get it in decimal form and round it. That's all we're doing with the Pythagorean theorem for the most part. Now there is one more longer problem, but that's the basic idea. All right, so let's do the longer version of this problem. All right, so find the length AB in the following figure. So what that means is we're trying to find that entire side. Well, one thing you can't do is you can't use the Pythagorean theorem with 10 and 17, because if you notice, there is no corner there. There is no symbol showing that's a 90 degrees. So it may look like a 90 degrees, but since it doesn't have that symbol, you cannot assume that that's 90 degrees. So this is not just a straightforward Pythagorean problem where that's A and that's B and we're looking for C. Okay. So what do we do now? Well, for Pythagorean theorem, you need right triangles. So notice the right triangle is right there. And so what actually is going to happen on this is we have two right triangles. So you have one over here and one over here, and both of those have a missing side. So basically, we're going to have to do two Pythagorean theorems. I'm going to call this X, and I'm going to call this Y when we set up the later problems. So if we can find those two separately, then we just add them together, and we have our time. Now, one recommendation I'm going to make, anytime we're splitting up a figure into two figures or sometimes three, redraw them and label what you have. So for that left triangle, so if that's a 90 degrees, this is just, they have to like on a line, those angles have to add up to 180. So if that's a 90 degree, that also has to be 90 degree. So that's not an assumption. That is one of those little geometric things, but those are both right angles. So that's 10 centimeters. That's 8 centimeters. And I labeled this X, so we don't know that side. So how does the Pythagorean theorem help? Well, that is our right angle. What that tells me is like that is like our A, that's our B, or vice versa. The important one is that's the C. Those can be interchangeable. The C has to be. So for A squared plus B squared plus or equals C squared, you can either leave this as A, or if you want to put that as X, That's going to be x squared. B squared is 8 squared. C squared is 10. So now we just do this calculation. 8 squared is 64. 10 squared is 100. Now, how do we solve for x squared? Well, first thing we're going to do is get that by itself. So we need to subtract 64 from both sides. X squared is equal to 36. Now that we have the square term by itself, now we can take the square root of both sides. Square and square root cancel. And then the square root of 36 is 6. So back on the original problem, we know that part is 6. So what about the other triangle? Okay, so now let's redraw that one. See what we have. So we know this is 8 centimeters. That is 17 centimeters. And we don't know that, so I'm going to call it y just to differentiate it from the x. All right, so we have a missing side or a right triangle. So we're doing the Pythagorean theorem. So what's our A or B and our C? Well, the one that really matters is that side opposite the 90 is our C. So that 17 is the C. This can either be your A or your B, doesn't really matter. So we know A squared is 8. If you want, you can put a Y. I'm going to, or B, it doesn't really matter. We're still finding that unknown side. It's equal to 17 squared. Now we'll do the arithmetic. 64 plus B squared is equal to 89. And so now how do we solve for B? Well, first thing we have to do is get the square term by itself. So we're going to subtract 64 from both sides. B squared is 225. Now we take the square root of both sides. And that square root is by itself. Square root squared cancel. We get B and square root 225, that's 15. Yeah, that's 15. So that side is 15. So now how do we get our final answer? Well, we know that side is 6, that side is 15. So just add them together. And 9 centimeters. So that's about as complicated as we're going to get with the Pythagorean theorem. Is instead of having you do one calculation of problem, you have to split the triangle up and do 2. If you're wondering, well, where am I going to use this in the real world? Just on a side note, woodworking is one of my hobbies. And the last project I did was a tall bookshelf. And I wanted it to get, I have 8-foot ceilings in my house. I wanted it as close to the top as possible. But I couldn't just make it 8 feet. Those were shelves. Because if I made it 8 feet, what happens is when you're if you've ever moved bookshelves, at some point, you're going to have to tip it up, to get it to stand up. And if that's already 8 feet, then you're not going to have enough room because you have 8, that's 8 feet plus a little bit more. So what I actually had to do was I said that can't be that, like that diagonal there would be 8 feet. And then I knew like the length of here, it was like a 10-inch bookshelf. And so then I did the Pythagorean theorem, figure out how tall it could actually be. So if you're into carpentry or woodworking, Pythagorean theorem is something that still gets used. So just thought I'd throw that out there because that is a direct application of what we're talking about in class. All right, that's it for the Pythagorean theorem. So like I said, 10.2, you look in the homework, there's one like definition style question to make sure you know like what the pieces are in the Pythagorean theorem. There's a couple of the basic Pythagorean theorem problems where you're either finding the hypotenuse or one of the legs. And then there's one like this where you have to do it twice. That's it. All I have for this video. I'll see you again when I get into 10.3 and perimeter. Have a good day.